Good afternoon, everyone. Thank you for being here. Let's face it, when it comes to SMP sealants, it's all about stability. It's all about our formulations standing up to time, weatherability, and harsh environments. It's not just about getting the job done, it's getting the job done exceptionally. And that's why I'm here today. My name is Tim Sato. I'm the Global Market Manager for Clariant's Adhesives and Sealants. And we're here to talk about a new product that we've developed with Omya. Omya folks are not here today because there was some medical issues, but John-Yves and myself are here to talk about a new stabilizer system for SMP sealants. Together, we did develop this technology as a partnership with Omya, and it's a product called AdWorks IBC 760, and it's a next-generation stabilizer that raises the bar on durability, weatherability, and long-term performance in SMP sealants. This joint collaboration really consisted of understanding the unmet needs in the market, as well as identifying the targets to address those unmet needs. Clariant has years of experience in light and heat stabilizers, while Omya has a vast knowledge in sealant formulating as well as application testing. Together, we divvied up the work and we created a new additive package that is patent protected and has global registration. Now imagine walking through modern buildings where the joints and every seal remains pristinely white and is clean after years of exposure to harsh environments and light. This isn't just an architect's dream, but it's a reality. And it's become a reality thanks to the great collaboration between Omya and Clariant. As I said, we know that stability is everything when it comes to ensuring coatings and sealants last in the environment. That's why this innovation delivers up to 150% longer service life, exceptional UV resistance, reducing yellowing and cracking, and improving heat stability. It helps formulators create a more reliable and sustainable product. Speaking of sustainability, we also adjusted the way we package our material. We're using 80% less paper in our packaging, and we put more material on a pallet, meaning that we could ship more, reducing CO2 emissions, and every little bit helps when it comes to sustainability. Oops. So what I'd like to do is turn it over to John-Yves. He is one of the inventors behind this new technology, and he can't wait to share this technology to you guys. So thank you very much. John-Yves?
Thank you. So hello everybody. Thank you very much, Tim, for the nice introduction. Let me now continue with some technical information on the product itself and how we have measured and evaluated the performance in sealants. First of all, maybe a quick recap on the product itself. It's a solution based on 3 different ingredients. We have developed this product with UV absorbers, HALs, and an antioxidant, which have been mixed together in given proportions and in order to develop the most synergistic properties and also to enhance I would say, the performance which are required to perform SMP sealants. So basically, based on this combination, we have been able to improve significantly the durability of SMP sealants in regards to improving the resistance to light, reducing yellowing, improving as well the heat stability. And I'm going to describe a little bit more what we have done and how we have achieved and evaluated these properties. We have used, I would say, a relatively well-known guide formulation for 1K SMP sealant formulation, high modulus, with the formulations that you can see here on the screen containing our solution with a standard dosage level of 0.8%. And then we have prepared and we have formulated the sealants according to, I would say, standardized procedures in the lab and also with test methods which have been discussed and approved together with Omya. So we have on one side, the lab part, preparing the samples, evaluating the properties by putting the samples in the lasering machines, and also testing the heat stability resistance through the heat edging test, which we have described here with the Omya test method. So based on these test methods and evaluations, we have been able to measure the performance and to compare it between different stabilizations. And you see here on the slide, we have compared our solution against the industry standard, which is composed of a UV absorber 326 plus HAL 770, which are, I would say, standard product on the market, and also against the next best alternative, which is a mix of UV absorber and HALs and antioxidant, which is called 5866. So here, very clearly, you can observe from the initial stage of the lasering up to 3,000 hours of xenon lasering test, you see a very interesting improvement in terms of reducing cracking, also not having strong yellowing issues with the SMP sealant containing our product inside. So the time to surface cracking is extremely, I would say, performing, and we can also claim very quickly here that even after 2,000 hours, the solutions which are not containing IBC 760 are already heavily damaged, and you can see the surface cracking as well. Another issue which is quite common in SMP sealants when you are formulating with chemistries of UV absorbers like benzotriazoles is about the problematic coming from the yellowing. Because actually when you are extruding, so just freshly from the cartridge, and then after a few seconds you have this yellowing appearance which is disappearing after a couple of minutes. This might cause also some troubles, and it might also result in potential complaints depending on the use at customers. This is mostly because the UVA 326 chemistry, but also, generally speaking, the benzotriazoles have a certain sensitivity to tin catalyst, and this is causing these yellowing issues, which can be with our solution completely eliminated. So that means when we compare the same sealant formulation containing on one side the UVA 326 and our product here with IBC 760, you do not see anymore this yellowing and this, let's say, color change after a few minutes just after extrusion. So that's a very interesting property that it also, which can be demonstrated here. But it's not all, and I want also to focus a bit more on the performance. That means more on the durability, or how we can extend durability of SMP sealants with our solution. On this slide, you can see a bit more about the performance which you can reach with filled SMP sealants. That means these products are containing mostly calcium carbonates, eventually some pigments, inorganic pigments. And you see from the lasering standpoint here, when we go from left to right, we have different formulations with the same base in terms of SMP sealants, but without any additives. You do not reach more than 1,000 hours, and then you have heavily cracks appearing on the surface, and also the physical integrity of the samples are really bad. When you compare with stabilized formulations of these SMP sealants, you see here with a standard formulation based on this combination 326 plus 770 and a little bit of antioxidant, at the same dosage level, we are already overperforming with our solution. And when you continue by increasing slightly the dosage up to 1.2%, you can reach 3,000 hours of lasering resistance, which means more or less 50% plus service life for the sealant. So that's, of course, quite significant, and you can see the trend is the same for transparent SMP sealants, where it's even more, let's say, important here, because you do not have calcium carbonate, you do not have any pigment which can be a barrier to the UV in terms of protection. So that means here you need to reinforce the stabilization by increasing the dosage and also providing the right UV package to the transparent formulation. And I think here it's very, let's say, self-explanatory when you look at these three pictures and from the same SMP, transparent SMP sealant without any additive, and then formulate it with, I would say, standard liquid stabilizers at the same dosage with IBC 760. Here we can go up to 5,000 hours of weathering compared to the standard package, which will not take the sealant more than 2,000 hours. So here again, excellent properties, excellent performance, and more than 150% increase in service life. Another important point which we need to mention is that our solution, it's a micronized powder which is quite easy to incorporate and which is demonstrating good solubilities in, I would say, the commonly used plasticizer in SMP sealants. So when we look at the curves, the dissolution curves, also solubility curves for mesamol, DIMP, and DINCH, you can see, of course, by increasing the temperature, you are facilitating the dispersion and the incorporation into the plasticizer. And that means the product is very easy to incorporate and has also good, I would say, stability once it is dissolved in the plasticizer. So it's a fine micronized powder which have excellent properties in terms of dispersibility and also compatibility in terms of compatibilities in these plasticizers. So here we have reviewed, I would say, the key requirements and also the key properties in terms of performance and durability, how extending the durability of sealants. But there is another thing which we would like to mention, and Tim was already explaining that in the introduction. We have been also able to optimize the packaging to further enhance the overall sustainability profile of the product. That means on one pallet you can put more product, more bags. So that means you can reduce by 80% the paper, increasing the logistic efficiency more than 125%, and that means, of course, this is a good way to reduce the CO2 emissions. So to recap on the product. Why is it a preferred option to formulate and to use in SMP sealants? Of course, when you look at the performance and the benefits which it can provide, it's mostly about improving the resistance to UVs and also improving the heat stability without any yellowing issues when it is extruded from the cartridge, and maintaining the good color stability during the storage in the cartridge. Of course, it goes together with the cost effectiveness, which can be considered as well, because you have in one solution a triple combination of ingredients. So that means you are able to reduce your inventory because you have one solution covering different formulations. So this is really the contributor to extend the service life of SMP sealants, as we have seen for both clear and filled systems. So last but not least, based on the success and all the benefits we have already observed from using AdWorks IBC 760 in SMP sealants, now we are exploring new territories, new applications, new technologies, which are, for example, exterior decorative coatings and also polyurethane sealants, which means today or at the time being, we are evaluating different properties in these new applications based on different criteria. So we are evaluating the solubility in more solvents, in compatibility with binders, also making different storage stability tests to make sure the product can be stable in liquid formulations, and also, of course, conducting weathering tests against some standards, which are more specific to coatings, for example. And we need also to make sure that it still performs well in terms of heat stability and also migration resistance in specific applications. So this is something we are working on currently, and yeah, sooner or later we will get some findings which we'll be happy to introduce later on in probably in the next presentation or in the next paper. If you are interested to learn more, of course, you are very welcome to visit the Omya booth in Hall 3C. I know it's late, we are the end of the third day, so there will be less visits, but always happy to support you. And I would like at that stage to acknowledge as well my friend from Omya, Chris Dobbins, who is my counterpart at Omya, and with whom we are continuing to work hand in hand to promote and to continue to develop potentially new solutions as well for SMP sealants. Thank you very much for your attention, and I'm happy to answer any question if you have.